Hello student, good evening. So today we are going to start what we just see the we will we will see what here simply just the difference between what material that is like conductor, semiconductor and insulator. Okay. So difference between these. Okay. So before before discussing this difference means in with respect to what electrical characteristic. So before we will discuss what about this solid or crystal. See, every crystal in this world, every crystal in this world has its own energy distribution structure. Okay, so energy distribution structure. So if we see here, there exists some complex band splitting of energy state. Okay, so in various solids. Okay, which leads to what complex band splitting is there. Okay, so there is a complex band splitting that occur in the various solids, which leads to what? Which leads to the variation in the energy band structure of the energy band structure between the various solids. Okay, various solids and which further leads to variation in the electrical in the range of electrical characteristic that we observe in the various material. So here we just simply take one energy band gap for understanding purpose. Okay, for basic to know the basic difference in the electrical characteristic. Okay, which is caused by what variation in the energy band structure. Okay, for that we will take a simple energy band gap. Okay, to understand this basic electrical characteristic, which is caused by what? Which is caused by the variation in the energy band structure. Okay, so let us see here first. This is what we are just differentiating. Okay, we are just knowing what difference in the electrical characteristic. Okay, electrical characteristic. See here the difference. Okay, so the basic difference basic difference basic difference in electric electrical electrical characteristic electrical characteristic electrical characteristic due to what? Due to variation in energy distribution, due to variation in the energy distribution structure, that we will understand by taking one simple energy band gap. Okay, so first we will take insulator. What? Insulator. First one we will see about insulator. Okay, so just write it is somewhat bigger. Okay, so insulator. Okay, so what is insulator? Insulator, the material which every material has what? Every material has allowed energy band. Okay, or not? Every material has allowed energy band. Okay, conduction band and valence band. Now the material which have band like this is my band, one band. This is my second band. Okay, second band. So every material has allowed energy band, valence band, conduction band. Okay, so valence band and conduction band, this band, every material has this. Okay, valence band, conduction band. Okay, now we are seeing what about insulator. Okay, what? Where it will go? Outside means it is going outside the crystal. The material which has allowed energy band, which is either empty, which is either completely empty, or which is either completely, forget this, conduction or valence band. Okay, so this is either completely empty or completely filled. That type of material what material that type of material has no free particle to move, hence it will not conduct at all. It will not conduct at all. Where this will go? Okay, where this will go? Outside the crystal? No, it is within the crystal. So if somehow it will get free, so where it will go? If it will sit here, means if it will sit here only, means it is again what completely filled. If it will sit here, means here in this discrete energy state, then it will violate what Pauli exclusion principle. Okay, Pauli, it will it will violate this Pauli exclusion principle. Okay, exclusion principle. It will it will violate Pauli exclusion principle rule. If somehow this electron will get free, and it will again come and sit in the another discrete energy state. Okay, so there exists two electron which will violate this Pauli exclusion principle rule. So therefore, which means that there does not exist any free particle. Okay, free particle to move. Okay, in which allowed energy band, those allowed energy band which is completely full, either completely full of electron, or either completely empty of electron. So those material will not conduct at all. Okay, so here you see all the energy state are empty. Nothing is there to move. Okay, no particle is there to move. So therefore it will not conduct at all. Okay, so these are insulator. See, now this is in the form of valence band, conduction band. Okay, so this is free space, means what? This conduction band is not there. It is actually we are representing it as what? It has one band. Actually it has what? Energy state, that is empty. That all the energy state are empty. Okay, empty. All the energy state are empty. That everything is depending upon what? Valence band. What? Valence band. This conduction band is always what? Empty. Always empty. This conduction band is always empty. Okay. So everything that will depend upon this. Okay, so here the gap is what? Here the gap is how much? Here gap is energy band gap. This gap lies in between 2.5 electron volt to 6 electron volt for what? For insulator. Okay, so this, now the insulator is a material which has allowed energy band, but that allowed energy band has either completely full of electron, and either completely empty of electron. Okay, so that insulator has allowed energy band which is either completely full of electron, or either completely empty of electron. So due to which there is no particle to move for the temperature greater than 0 degree Kelvin, and hence this insulator will not conduct at all. But thermally few particle is there, which is not enough to make this insulator as conductor. Okay, so therefore this type of material is called insulator. And here the energy band gap energy band gap is nothing but the amount of energy that you have to give externally, so that in order to make this insulator conductor, that energy is required at least 2.5 electron volt to 6 electron volt. That is at least. Okay, so this is what insulator. Okay, so band gap is this. Okay, allowed energy band is either completely full of electron, or either completely empty of electron. Okay, empty of electron. That energy band gap is nothing but externally how much energy you have to give to this insulator in order to make it as a conductor. That is 2.5 electron volt to 6 electron volt, which is very large. Okay, which is very large. Okay, so now we will see next next is semiconductor. Semiconductor. So semiconductor, we will see this in difference of electrical difference. Okay, so we are differentiating it electrically, all the material. Okay, so this is my semiconductor. Semiconductor. And one thing is there, the resistivity. The resistivity of insulator. Resistivity of insulator is very large. Okay, resistivity of insulator is very large. Okay, so this is my resistivity of insulator, that is very large, and hence conductivity is very small. Conductivity of insulator is very small. Okay, so this is my conductivity. This conductivity is nothing but 1 by resistivity. Okay, so this is about insulator. Okay, this is for insulator. Now coming to what semiconductor. Coming to semiconductor material. Semiconductor material are those materials which have allowed energy band in such a way that the allowed energy band is either almost full of electron, or either almost empty of electron. Okay, so those material are called semiconductor. And this type of allowed energy band, these means those type of allowed energy band have free particles to move, and hence this type of material will conduct. Okay, so this type of material is able to conduct. So see here, allowed energy band. Between these, what are these are discrete energy state. Okay, so discrete energy state. Now the allowed energy band, which is either almost full of electron, let us say this is almost full of electron. Okay, almost full of electron. Only two discrete energy state are empty. Meaning that what is moving here, actually movement is about what? Movement is about always about minority charge carrier. Here minority charge carrier means what? Here electron is in majority. Then what should be the minority? Minority should be what? Or temperature greater than 0 degree Kelvin. Okay, so when the temperature is greater than 0 degree Kelvin, this electron will gain the thermal energy and jump to the higher energy state and sit into the higher energy state, because this higher energy state is empty state. Okay, here it can sit very easily, and therefore a positively charged empty state will get created, and hence this electron will alternatively fill one positively empty charge, positively charged empty state, and creating the next positively charged empty state. So therefore this motion is almost equal to the moment of positively charged empty state. Means here the current is almost due to what? Due to the positively charged particle. Okay, so due to positively charged particle. So this is about when the allowed energy band is almost full of electron. In next case, when the allowed energy band is almost, either if the allowed energy band is almost empty of electron, means it has only, there is so many energy state. Okay, so let us say it has only two electron. Now see here, which one is majority, and which one is minority? Electron here is in minority, here is in majority. Here electron is in minority. Okay, electron is in minority, therefore here current should be due to negatively charged particle. Okay, so here the current is due to negatively charged particle. When the temperature is greater than 0 degree Kelvin, then this electron will jump to the higher energy state. Okay, higher energy state means it is like a conduction band for them. Okay, so therefore they will freely move. Okay, so therefore here the current is due to what? Due to the positively charged. Here the current is due to electron. Okay, here the current is due to electron, means here current is due to negatively charged particle. Okay, here the current is due to positively charged particle, because the here electron is in majority charge carrier. Here the electron is in minority charge carrier. Wherever the electron is in majority charge carrier, here if you will see here, this is only about what? This is only about, I am talking about in case of valence band, not in case of conduction band. Okay, in case of valence band like this. Okay, majority, that depend upon majority and minority charge carrier. Okay, within the allowed energy band. So here electron is majority, so therefore the current is due to positively charged particle. Here the electron is minority, means current is due to the negatively charged particle. Okay, so therefore the semiconductor is a material which has allowed energy band, which is either almost full of electron, or either almost full of electron, okay, which is almost full of electron, either either almost empty of electron, either almost empty of electron, either almost full of electron, but not completely. Okay, so those type of material is called semiconductor, and they are able to conduct when the temperature is greater than 0 degree Kelvin. Okay, here the current is either due to positively charged particle or negatively charged particle. Okay, so this type of material is called semiconductor material, and here in case of semiconductor material the resistivity is variable. Okay, so means what, here we have a control over the resistivity of semiconductor. We can vary it up to the large magnitude, and we can vary its resistivity to the lower magnitude. That depend upon what doping, and doping depends upon you and all of us, means how much doping we will do into the material. Okay, according to that the resistivity will vary, and according to that conductivity will vary. Therefore, ultimately the conductivity we have control. Okay, so therefore we can vary the conductivity and vary the conductivity. Okay, so in case of semiconductor, this is one beauty of semiconductor. Okay, so it allows us to change the property of this semiconductor material by changing its resistivity. Okay, so here the energy band gap. See, this is my conduction band, and this is my valence band, and this is what energy band gap, and this energy band gap is almost 1.1 electron volt. Okay, so these are valence band and conduction band. Okay, so this is semiconductor material. Okay, so now next we will see what conductor. So what is conductor conductor are those material which has allowed energy band. Okay, which has allowed energy band, and those allowed energy bands will get overlap with each other. Okay, will get overlap with each other. So they will get overlap with each other. So therefore, there does not exist any energy band gap. There does not exist any energy band gap. Either you can represent this like this. Here, valence band is completely full of electron, and the conduction band is also partially full of electron. Okay, so valence band is full of electron, and conduction band is partially full of electron. Means already there is a lot of electron present in the conduction band, and hence it has large conductivity. Okay, it has large conductivity, and here does not exist any energy band gap. Okay, between the conduction band and valence band, because already there is a lot of electron in the conduction band, which is partially filled. Okay, partially filled. Either you can say, but there is a overlap between the two allowed energy band. Okay, so there is a overlap between the two allowed energy band when energy band formation is there. Okay, so when allowed energy band formation is there. Okay, so here there is no energy band gap. This energy band gap is not there. Okay, so they will get overlap with each other. So this is what overlap between two band. Okay, so there is no energy band gap. Okay, for what conductor. So there is overlap. Okay, so either you can represent this by this. Okay, valence band is completely full, and conduction band is partially full, and hence resistivity of conductor is very low. Resistivity is very low in case of conductor. Very low, very low resistivity, and conductivity is very large. Okay, so very large. So therefore, there does not exist any energy band gap. Okay, any energy band gap. This is about conductor. Okay, so this is about conductor. Conductor has lot of free electrons. Okay, and its conductivity is very large. Okay, so this is all about the difference in the electrical characteristic of these material: insulator, semiconductor, and conductor. Okay, so this is all about this topic. Okay, so now next we will see what topic will come. Okay, so thank you for all for seeing my lectures. Okay, so thanks a lot.